Hello everyone. We're going to look at one of my favorite features of my Nexus MBE control software today, which is the recipe builder. Now we created the recipe builder because while the recipe scripts themselves are very powerful, they do sometimes take a long time to write, especially for new users. And we want to speed up that process. Now let me explain. So what you might do when you're writing a recipe is you might want to open a shutter. So for gallium, for example, and then you might want to wait a certain number of seconds. And then you're going to close that shutter. And you build up a recipe like this sequentially. It's easy to understand what's going on, but you're writing it line by line. Now with the recipe builder feature, you can create an entire recipe to grow a sample within seconds. And how many seconds that takes, I'm going to leave you to time for yourselves, but let's go through it right now. I'm going to go to the recipe builder. We're going to do an outgas and oxide remove, which is usual when you're starting a sample. We're going to use arsenic as the overpressure species, and we're going to outgas at 400 degrees. This is all remembered from last time for half an hour with no arsenic on, but then oxide remove at 600 degrees for 15 minutes with the arsenic on. And finally, we're going to cool it to the growth temperature, which is 580 degrees. Wait there for 5 minutes, obviously keeping that arsenic on. So we're going to go ahead and paste that script in, and there you go. That's the oxide remove part written and interpreted down here in what's going on in terms of the substrate temperature and the arsenic being turned on. Obviously, there's no growth at the moment. So this is just blank over here, but what we want to do now is add a layer. So we want to put something into this recipe. I'm going to go back to the recipe builder, add in a layer. Now we're at 580 degrees. So let's add in some aluminium instead of the indium for this layer. We've got our 5:3 ratio set here, and our growth rate is total growth rate. The gallium and the aluminium is going to be 0.282, which on gallium arsenide 001 is 1 monolayer a second. And we've got no doping, but we want it to be 500 nanometers thick. So we're going to hit this button. It's going to tell us exactly the temperatures that we need in our sources, that the fluxes in atoms per nanometer squared per second, the beam equivalent pressure that corresponded to those fluxes when the software measured them automatically with the flux gathering feature, and the growth rate for the individual species, the gallium growth rate, the aluminium growth rate. And as you can see in the number of decimal places that we've got here in this resolution, this is 9 times less than this, which will give us our ratio here. Arsenic is oversupplied, and the growth time is going to take us 1,773 seconds. I'm going to paste that in. We have our layer grown, interpreted. Here we can see the arsenic needed to be increased here. The shutters are open for the gallium and the aluminium here. And we now have our layer given to us that it's gallium, aluminium arsenide, 500 nanometers thick, 90 to 10. So that was the only layer we're going to grow. Let's say we want to cool our sample down now. We go back to the recipe builder, back in, set cool down. And this is similar to the outgas and oxide remove. We're going to set the arsenic as the overpressure species. We're going to cool down the substrate to 400 degrees, wait there 5 minutes. Obviously, the arsenic's going to be on during that time. And then we're going to cool down to 100, wait there 5 minutes, and the arsenic can be off. We're going to paste that in, close this, and there we go. The script recipe written in seconds, however many seconds that took, and completed very easily. I hope you enjoyed the video.